Hi everyone. In this video we are going to see assignment number 9. The first question is, for the given PLL circuit NE565, what is the free running frequency F 0? Here F 0 equal to 1 by 4 R1 C1. This is the formula for free running frequency of PLL. Here R1 equal to 12 kilo ohm and C1 equal to 0.01 microfarad. If we substitute both, we will get 12 kilo ohm R1 and C1 equal to 0.01 microfarad. If we substitute these two, we will get 2083.33 hertz, which can be rounded to 2084 hertz. The given option is A. The second question is, for the same PLL, what is the lock range? The lock range formula for PLL is del FL equal to plus or minus 7.8 F0 divided by the supply voltage. Here F0 what we found is 2084 hertz. If we substitute, and the supply is plus 10 volt and minus 10 volt, therefore it is V equal to 10 minus of minus 10 is 20, therefore it is 7.8 into 2084 divided by 20. If we substitute all those values and use the calculator, we will get del FL equal to plus or minus 812.5 hertz. The given option A. Question number 3, what is the capture range? Del FC. Del FC equal to, for PLL, the del FC equal to, formula is del FL divided by 2 pi into 3.6 kilo ohm, that is the resistor value, and the C2 is the capacitor value, whole power 1 by 2. This is the capture range formula. Del FL what we found is 812.5 hertz divided by 2 pi. R is, this value is internal, 3.6 kilo ohm is internally present inside the IC. So 3.6 kilo ohm into C2 is 10 microfarad, which is given in the circuit, whole power 1 by 2. C2 value is 10 microfarad. After substituting these values, we will get del FC equal to plus or minus 59.93 hertz. The fourth question is, in a VCO, if the input frequency Fs equal to 30 kilohertz and free running frequency F0 equal to 32 kilohertz, there is no voltage here, and voltage to frequency conversion factor of VCO is 8 kilohertz per volt. What is the frequency shift? That is the first question. So far, the frequency shift is nothing but the difference between the incoming frequency and free running frequency. That is nothing but it is 2 kilohertz. 30 minus 32 or 32 minus 30, that is 2 kilohertz. That is the frequency shift. Option B. The next question, fifth question is the change in the DC control voltage during the lock. So the lock is happening for 2 kilohertz. So the free running frequency, that has to move from 32 kilohertz to 30 kilohertz. It has to reduce. Okay. So to make that change, we know that kV equal to the factor frequency conversion, voltage to frequency conversion factor, kV equal to del F by del V, and here the del F is 2 kilohertz divided by del V, what we have to found, and the kV value is 8 kilohertz per volt, which means del V equal to 2k by 8k, and that is nothing but 0.25. Option B. Question number 6. The free running frequency of PLL is 300 kilohertz and the input frequency is 320 kilohertz. What is the phase detector output? That is the question number 6. For PLL, the phase detector is nothing but what? Simply the multiplier. Fs is incoming frequency, F0 is the frequency from VCO, and the multiplier is producing the Fs plus F0 and Fs minus F0. That is given to low pass filter, and low pass filter is produced allowing only Fs minus F0. Fs plus F0 will be eliminated. Okay. So here the question is, what is the phase detector output will be for two frequencies? Fs equal to F0 equal to 300 kilohertz and Fs equal to 320 kilohertz here, and therefore the output will be 320 minus 300 is 20 kilohertz, or else it is 620 kilohertz for the multiplier. Okay. So here the given option is 20 kilohertz, therefore we are choosing that one. And PLL gets locked for the low pass filter value. Here in the above discussion, the Fs equal to 320 kilohertz and F0 equal to 300 kilohertz, and the product will be Fs plus F0, Fs minus F0, and the low pass filter will allow only Fs minus F0, and that has to be 20 kilohertz. So the low pass filter value should be greater than 20 kilohertz. In that case only, the 20 kilohertz signal will be allowed. So 5 kilohertz is not possible, 10 is not possible, 15 is not possible. Only 25 kilohertz cutoff frequency is possible. Therefore, option 25. And the last question is, the free running frequency of PLL is 300 kilohertz and the low pass filter cutoff frequency is 10 kilohertz. What is the incoming signal should be? The same logic. We have a multiplier. Fs is incoming frequency, F0 is frequency from VCO, and it will produce Fs plus F0 as well as Fs minus F0. And I have low pass filter next. That will allow only Fs minus F0. Okay, low pass filter is like gate. Okay, so the person who can enter into that gate means the door. Into that door means whoever having the low height than the actual height of the door can enter into that door. Okay, so here it is having 10 kilohertz and free running frequency is 300 kilohertz. What should be the Fs? So the difference should be less than 10 kilohertz. The difference between Fs and F0 should be less than 10 kilohertz. 10 kilohertz is nothing but what? Low pass filter cutoff frequency. Therefore, so 315 is not possible, 320 is not possible, 325 is not possible. Only 305 can be the incoming signal frequency, 305 kilohertz. So that the difference will be 5 kilohertz and it can pass through low pass filter. So the option is A. Thank you.